Okay, let's get started. Hold on. I'm going to bring this up to me. Hey, okay, good. We're back. So, welcome back from Thanksgiving. I hope everybody had a great break, got some sleep in, ate some turkey or ham, and deviled eggs. That's what matters. We are ready for the last week. Now, I sent everyone an email. You should have seen an email in your inbox today. Earlier, actually, a few hours ago, I sent it, and it was just over the instructions for the rest of the week. I'm going to go over them again right now before we get started. So, this is the last week. We made it. Yay. It's almost done. Today, which is Monday, we're going to go over chapter 6. This is stuff that's going to be on the final, but it's not going to be on a regular test. Just a little bit of information from chapter 6 because we have to hit a little bit of matrices stuff. Not a big deal. Actually, it's very basic kind of algebraic stuff. We might not need the calculator. I know I said you needed it, but we might not need it for what we're going to do. So that we're going to do that today. Wednesday, though, we're going to study for the final. So my goal Wednesday is for you actually to come in prepared with questions. So I would look back at all 5 regular tests and the homework from today and have questions prepared because the test is cumulative. It's over everything we've talked about this semester. So I want you to go back, look at your test, see what you missed, see what you got right. I mean, because it's been a while since we went over, test 1, 2, and 3. Those were a while ago now. So go back, check them out, see what you missed, see what you got right, see if you just need kind of a refresher because you might have got it right on that test, but you're not sure how you got it right. And then come with questions on Wednesday. So that's Monday, Wednesday. Friday is the test. So the Friday will be the test, December 4th. It'll be open from 8 to 5. So you'll have to get it done between 8 and 5 on Friday. If you cannot do that, I know I've had one student already email me because she gets off work at 5 o'clock. So if you cannot do that, please get with me to make an accommodation beforehand. Don't get with me after because once it's over, it's over. So this isn't like the regular test where some of us have had to do them a few days late for whatever reason. I can't have it that late because I have to turn in final grades pretty quickly after that. So anyway, so the final test is Friday. If you I know I've said this in many videos up to this point. If you need accommodations, just please get with me, and I can make that work. Okay. It's roughly 40 questions. In that email, it kind of sums it up. So if you read the email, it really does sum it up well. Do you guys have any questions in here? Let me make sure my volume's up. Any questions about the rest of the week? Okay, that's fine, Sherry. Email me because when you email me, then I can put that in. I'll give you some extra time. I'll go over it with you in the email. Yeah, just get with me. Not a big deal. Any questions? Okay, let's get started. So today, I don't think you'll need a calculator. I know I said that, but I think I'm lying, actually. Let me video over. Bing. Good. Tune them together. So today we're going over chapter 6. Chapter 6 goes over the matrix. And if you're asking yourself, what are you talking about when you're saying the matrix? That's fine. I treat this like you've never seen it before. And if you have, that's fine too. We'll probably go over some stuff maybe you haven't seen in a while. So a matrix is just a way to create a group of numbers. You can think of them as equations, that's fine. But for us, we're going to think of them like a group of numbers. Let me just start with kind of a basic matrix. We'll say it's 2, 1, -3, 0, 4, and 5. Okay, this is what a matrix looks like. And this matrix has, now each of these are kind of like coordinates on the matrix. There's 6 components, I guess is a better way to think of it. 6 components to this matrix. It has 3 rows and 2 columns, and that's actually where the order comes from. So the order of a matrix is always rows by columns. So rows by columns. So for this matrix, the order would be 3 by 2 because it's 3 rows, 2 columns. Okay, no big deal. So and each coordinate kind of corresponds to a spot. And to notate that, like, let's call this matrix A. We'll call it matrix A. So if I wanted to call a single component or a single part of the matrix, the way I would do that is actually, for some reason, I don't know why they use lowercase notation, but use lowercase notation. And then the coordinate for the part or the component of the matrix is always its row by its column. So like, let's say we wanted to call out 4 here. It would be row 3, column 1, right? Row 3, 1, 2, 3, and then column 1. So it would be 3, 1. So A31 would be 4, okay? And if I wanted, let's say, like the number 1 there, well, that's going to be the first row, second column. So it would be 1, 2, would be 1, okay? This is like the easiest question on the final, actually. It'll give you a matrix like this, and it's going to say, what's the order or what's the position A31? Oh, it's just 4. Or A12. Oh, that's just 1. No, the very bottom position is always the order. So like if I wanted to call out 5, it's going to be A32 because it's third row, second column. And that's actually the order as well. So that's going to be 5. Okay, no big deal. Hopefully not a big deal. But we do need to know the order. The order is important when it comes to actually the operation of matrices, which, and I know weirdly for this chapter, I'm going to start in section 3. So it's going to be 6.3. And if I wrote this book, I would have made 6.3, 6.1. I would have made it the first section. But I did not write this book. I do not make the money from selling this book. Let me get there. Hold on. So 6.3, and you'll see it's titled something like, operations and applications of matrices. So we've got a matrix, we've got positioning, and then your book goes over, equality of matrices. So for 2 matrices to be equal, they have to have the same exact order. So let's look at another example of matrices with different orders. Let's say I had, we'll call this one matrix A. X, Y minus 2, 4, Z, pi, and Q plus 1. Okay. I know that one looks goofy, but notice each one of these is a component. Oh, wait, this is the same order as the last matrix. Okay, hold on. Let's change this up. Mark that out. Mark that out. Sorry if you're using pen. Let's say it's X, Y minus 2, 4, Z, pi, Q plus 1. Okay, just to make a different example with a different order. So X, Y minus 2, 4, that's the first row. Z, pi, and Q plus 1, that's the second row. And notice there's 3 columns here. So if I asked you for the order to this matrix, well, we've got 2 rows and 3 columns. So it's a 2 by 3 matrix, okay? The order on this one is a 2 by 3. So if I want to create equality, or if I want to say another matrix is equal to this matrix, what happens is each of these components, whatever their position is, it has to be equal in the other matrix, which means we have to have the same order. So let's say we've got matrix B here. We'll say this is 8, 3, 4, 10, pi, and 15. Okay, 8, 3, 4, 10, pi, and 15. And notice this matrix has the same exact order of 2 by 3, right? We've got 2 matrices with the same exact order, 2 by 3. And if I say, hey, if A equals B, find our variables. We got X, Y, Z and Q. Okay, if A equals B, or given A equals B, either one's fine, find X, Y, Z, and Q. Well, we know if these are equal to each other, what it means is that their components are equal. So like X here, which is really the 1, 1 component, it's going to be equal to the 1, 1 component of B. So X is just going to equal 8. Okay, very easy. And then same with Y2 right here, Y minus 2, I should say. This is the 1, 2 component. So it's going to be equal to the 1, 2 component of B. So Y minus 2 is equal to 3. Now, we got to solve this one out. So add the 2. And we get Y equals 5. Okay. The 4 equals the 4. That's no big deal. There's now these two have to equal each other. I couldn't have written 5 here. It would make this not true. Z equals 10. Another easy one. Pi equals pi. And Q plus 1 is equal to 15, right? Q plus 1 equals 15. This 2, 3 component is going to be equal to the 2, 3 component over here. So I'm going to subtract the 1, and I get Q equals 14. Okay? And this is just equality of matrices. It's actually, the math in this section isn't hard. We're going to go over kind of a goofy thing at the end of this lecture that's kind of goofy. But overall, the math of these matrices is not that difficult. And when the math gets too difficult, we will be using a calculator. Okay? We'll go into how to use this in the calculator. Questions before I keep going on? This stuff's not too rocket science-y. Just that makes sense. To always simplify it down. Well, it'll be given. So like the question, yeah, Sherry, the question is going to give you the two matrices, and then it's going to ask you this. So like if A equals B, find these four variables. So we do have to get it to a point where we know X, Y, Z, and Q. So yeah, I guess if that's what you're meaning by simplify, yeah. You just got to answer whatever they're asking. Yeah, whatever they're asking in the question is what you need to simplify it down to. Okay. So now the first operation your book goes over is actually just addition and subtraction. Addition and subtraction is very easy. It's probably exactly what you're thinking it is. But again, to do addition or subtraction, we have to have the same order. Okay, we have to have the same order. So if we looked at, let's do just some different ones. Let's say I had 4, 2, -3, and 1 plus, now look, this matrix, I'm going to write the order underneath. It's only got 1 row and 4 columns. So it's a 1x4 matrix, okay? And if I'm going to add that to another matrix, it also has to be a 1x4. So let's say -3, 7, 4, and 0, okay? Again, this is a 1x4 matrix. Now, if this was not 1x4, we just could not add them together, okay? You can't just smush them together. They both have to be the same. And just like the equality, with addition and subtraction, you're going to perform that operation to the components. So like it's going to be 4 plus -3. That's going to give you the first component in your additive matrix, okay? And then 2 plus 7, oh, that's just 9. -3 plus 4, that's a 1, right? And 1 plus 0, that's also 1. And that's our solution, right? So if we wanted to add these together, we'd have 1, 9, 1, 1. Okay, these aren't all one number. This is 4 different components, 4 different numbers. 1, 9, 1, 1. Okay. Let me go down. Okay, so if we did like, well, let's just do subtraction on one. Let's say we had, let's say 4, 2, -3, -4, 8, and 0. Let's say we want to subtract off Let's see. Now look, this is what, 3 by 2. So this one has to be 3 by 2 for subtraction. So let's say we had -1, -8, 0, +4, and then let's say 2 and -5. Okay. So again, we have another 3 by 2 matrix. And so if we want to do subtraction, it's going to be the exact same as addition, right? In that, except we're subtracting, but it's going to create another matrix of the same exact order. And we're just going to subtract for each component. So 4 minus a -1, that becomes a +5, right? 2 minus a -8, no, that's going to be a +10, right? Because the two negatives make a positive. Close off the matrix. -3 minus 0, well, anything minus 0 is itself, so that's just going to be -3. -4 minus 4, it's going to be -8. 8 minus 2, 6. 0 minus a -5, so 0 plus 5, right? That's going to be a +5. And then you see it created a 3 by 2 matrix. Because when you add or subtract matrices, you have to, they have to have the same order. Okay, when you add or subtract matrices, they have to have the same exact order. Okay. Questions? Oh yeah, there's one more kind of easy operation. Before we get to one that's a little more intense, there's one more easy operation that your book goes over, and it's called scalar multiplication. Okay, it's called scalar multiplication. So if a scalar multiplication just means we're going to multiply a number through the matrix. So let's say the way your book and test likes wording these is they'll give you like two. Let's say they give you two matrices. So let's do just kind of a basic 2 by 2. So 4, 0, -2, 3. That'll be A. B will be -1, 4, 2, and 9. I'm just making these up. And what they're going to do is they're going to give you kind of a string and expression, okay? And we're going to put it in and then simplify it down into one matrix. So they'll give you something like 2A plus B, and they'll want you to find 2A plus B. And now look, this 2 is a coefficient of A, and what that is, your book calls it scalar multiplication, because you're scaling A by 2. And the way this writes is 2, and then you've got 4, 0, -2, 3, plus B, which is -1, 4, 2, and 9. And if you have a single number outside of the matrix, a coefficient to the matrix, which is the 2 here, you've just got to multiply the 2 to everything inside the matrix. Now you have to do that first before you add. It follows the same rules of order of operations, right? You've got to multiply before you do the addition. You got to multiply the 2 before you do the addition of the matrices. So I'm going to multiply the 2 throughout every single component. So I get 8, 0, -4, and 6, right? Plus -1, 4, 2, and 9. So you got to multiply that 2 through to all 4 parts. And then you can do the addition like we did in the other example. So 8 plus a -1, that's 7. 0 plus 4, it's just 4. -4 plus 2, that's -2. 6 plus 9, that is 15. Okay? And that would be our solution. That's really a simplification. It's not technically a solution, but that's what our answer would be. I'll put it like that. Okay. Do you guys have any questions? I'm not trying to go fast. It's just the math isn't that hard, right? So it feels like I'm kind of speeding along. And if you need me to slow down, please just let me know. I'm going to steal one from the book just to make sure we know how to do these. Okay, yeah. It does solve some stuff. Yeah, this is a good example because I've really done one like this. Let's look at, we'll do number 20. Yeah, number 20. It's a little different. This is on page 624. Number 20, it gives us A and B here. A is -3, -7, 2, -9, 5, 0. B is -5, -1, 0, 0, and 3, -4. Now number 20 asks, or gives us 3x minus A equals B, and we're supposed to solve for x. I'll write that down. Solve for x. Now, before I solve for x, or before I plug what A and B are, what's what I'm trying to go for? Before I plug the matrices in for A and B, I'm going to solve for x like it was a regular equation. Okay, well, I guess you don't have to. Nah, let's not do that. We'll just plug it in. So I'm going to plug in what we know. 3x minus -3 minus 7, 2, -9, 5, 0 equals -5, -1, 0, 0, 3, -4. Well, the first thing I would need to do is I've got to add this matrix to the other side, right? So I'm going to add all of this. I'm not going to rewrite it. Okay, I'm going to be a little lazy here. I'm going to add it to the other side, and we can add these together, right? They're both 3 by 2 matrices, so we can add them together. Now I'm going to be even lazier and not even write this out. And I'm going to add the 2 matrices because I know what they are. They're up here. So it'll be -5 plus a -3, so that's going to be -8, right? -1 plus -7, so it's going to be -8. Hey, same thing. 0 plus 2, that's going to be 2. 0 plus -9, that's -9. 3 plus 5, that's 8. That's 8. -4 plus 0, that is -4. Okay, so I had to add the 2 matrices together on the right-hand side. Now I've got to get x by itself. Now look, we can divide 3 on both sides, but for matrices, you need to think of it as multiplying by 1/3. Okay, it's scalar multiplication, it's not scalar division. So to get the 3 to go away, we're going to multiply both sides by 1/3. Okay, it gets 3 times 1/3 is just 1. And then multiplying 1/3, just like we multiplied the 2 into the previous example, we've got to multiply this 1/3 to every single part of the matrix. Well, 1/3 times -8, that's just -8/3. Okay, same thing for the other -8. 1/3 times 2, that's just 2/3. I'm going to run out of room here. -9 times 1/3, well, that's actually divides evenly. -9 times 1/3, that's 3. So -3. We get a positive 8/3 here. And then a -4/3. And that's our solution. Okay, I'm going to rewrite this one because I feel like I jammed up in here. So -8/3, -8/3. 2/3, -3, 8/3, and -4/3. That's our solution. That looks better. Okay, that's our solution. You could have solved for x at the very beginning and then just done the operations. That's fine. You would have wound up in the same spot. What I mean by that is if you said, oh, add the A over, so we would get 3x equals, let's say B plus A, and then multiply the 1/3 by everything. Okay, now you'd have to do the addition first and then multiply the 1/3 through, and you would have wound up with the same exact answer. Okay, you would have wound up with the same exact answer. And both are fine. There's no necessarily right or wrong way to do that. Okay. Questions before I go on to now multiplying these things are a little different, and yeah, multiplying these are a little different. They take a few more. There are a few more steps than the regular addition or subtraction or kind of the basic operations. So stick with me, okay? Stick with me on this. It takes a little bit to kind of get this pattern down, but I like using a goofy food analogy. And anytime I can use a goofy food analogy, it helps. It typically helps students remember how to do this. So let's say I've got two matrices. Let's say 4, -2, 0, 1. Okay. And then I've got another matrix, let's say 3, 5, -1, and -3. Okay. Now, to multiply matrices, it's not that the matrix has to be the same. It's that the columns of the first have to equal the rows of the second. Now, this one's fine. It's 2 by 2 and 2 by 2. I'll give you an example of why that's true for the next one. I just want to get the pattern down for this one. But a quick way to check to see if they're multipliable, I guess is a good way to think of it, is if you write their order. So this is 2 rows by 2 columns, 2 rows by 2 columns. So write their orders underneath each one. If these two numbers match, then it means that we can multiply these two matrices together. Okay, these two. So this is the column of the first and the row of the second right there has to match. And if those match, then we can multiply. Okay, so here's how we do this. And it is goofy. I really need your attention right now because this is kind of a goofy, it's kind of goofy. Okay, so what we're gonna do is I think of this like breadstick. No, let's do cheese sticks. Okay, I think of these like cheese sticks. Okay, so each row is gonna be its own cheese stick. So here is my first cheese stick. Okay, that's my first cheese stick. And I'm gonna dip them into the sauces, which are the second, that's the second matrix, okay? So here's the first sauce bucket. And of course, typically people like marinara. So we'll call this our marinara bucket, okay? And what we're gonna do is we're gonna take this cheese stick and you kind of have to visually think of breaking it off and then dunking it in, okay? So the -2 kind of goes first in that, right? And think about this, the -2 would overlap with the -1 and the 4 would overlap with the 3. If I actually physically did that, took it off, dunk it in, the -2 would overlap with the -1 and the 4 would overlap with the 3, okay? Kind of make a bigger matrix over here. Look, this is gonna be my first component. Now, when I do this, if it overlaps, if the numbers overlap, you're going to multiply them. And then you're going to add all the other parts to this. So what I mean by that is when I take this off and I dunk it in, the 4 would overlap with the 3. So it's going to be 4 times 3. The -2 would overlap with the -1. So I'm going to add -2 times -1. Okay? 4 times 3 and -2 times -1. That's going to be my first component, like 12 plus +2. It's going to be 14, okay? That's my first component. So now I've got to dunk it into the next sauce. And I'm going to tell you, if you've never had honey mustard with cheese sticks from Sonic, it's quite delicious, okay? I know usually a lot of people do like ranch. I know, ranch. No. Honey mustard with these things is so good. Okay, we'll do another example with another row or another column, I should say. And we'll use ranch. Okay, but I'm going to do the same exact thing, guys. I've got to use the same cheese stick though, and I'm going to dunk it now into this second column. Now, when I do that, now look, I'm still on the first column or first row up here. So I'm going to take the 4 and the -2 and I dunk it in. The 4 is going to be over the 5, so 4 times 5. Plus the -2 is over the -3, okay? Now, there's no more sauces to dunk this in, so that means it's gonna stop right there, okay? We're gonna stop right there. And now we've got to go on to our second cheese steak. And just to get us in the Christmas mood, let's use red for the Christmas season, okay? And we're going to do the same thing. So if I dunk 0 into there, the 0 is going to be on top of the 3. Oop, I'll use black just to be consistent. 0 times 3. The 1's going to be on top of the -1. And then into the next, into the honey mustard, we'd have 0 on top of the 5 and 1 on top of the -3. Okay. And now I'm just going to do kind of some basic math here. 4 times 3 is 12, plus -2 times -1 is 2. So that's going to be 14. 4 times 5 is 20, plus -2 times -3 is 6. So that's going to be 26. 0 goes away. That's nice. 1 times -1 is -1. 0 goes away there because 0 times 5 is 0. 1 times -3 is -3. So this would be my multiplication matrix. If I want to multiply those two together, that's what I would get. Pretty cool. Okay. Any questions other than, I think I need to see that again, and then I want to try it on my own, see how I do. Okay. Questions, comments, concerns? Okay. Okay. So let's do one, and let me show you why the order matters and why the row and the columns have to all kind of equal out there. Let's look. I'm going to steal an example from your book. I remember they do a good example of this. Give me just a second. Oh, yeah. So let's say we had two different matrices. The first one's going to be another 2 by 2, 4, 2, 1, 3. And then we've got another matrix B that's going to be 1, 2, 3, 4, 0, 2, -1, and 6. Okay. So matrix A is 4, 2, 1, 3. And then B is 1, 2, 3, 4, 0, 2, -1, and 6. Okay, so order matters. And even that last example we did, if you flip the order around, it's going to give you a different solution. Okay, it's going to give you a different answer. But I want to start with when these wouldn't be able to work out. If I did B times A. So now look, this order is 2 by 2, right? This is a 2 by 4, right? So if I wanted to do B times A, it would be 1. Now, you don't have to write this out if you don't want to, but I just want to show you why it won't work. You can just watch me, and that's fine. 4, 2, 1, 3. Okay, so notice this is 2 by 4, and this is 2 by 2. Now, automatically, I can see, like, this is not equal, right? That 4 is not equal to that 2. Therefore, you won't be able to multiply these together in this order. And if I think of the dunking scenario, okay, look, I've got 4 components here to dunk into a column with only 2 components. They don't fully overlap, okay? Now going back to that last example, they have to overlap completely, okay? That's why the number of row or columns has to equal the number of rows over here, okay? That's why. So it has to fully overlap. If you do this order, you'd have a four components or 4 parts, but it would only have 2 to dunk into. It doesn't work out right, okay? So look, we just can't multiply these. Can't multiply. We can't multiply B times A. But what's interesting, didn't mean to throw a marker like that. What's interesting is we can multiply A times B. If we flip the order up here, we'd have 4, 2, 1, 3 times 1, 2, 3, 4, 0, 2, -1, and 6. If we flip the order here, this is 2, 2, and this is 2 by 4, right? And notice these match. So we can, and think about it, if I just look at the very first step, I'm going to use a whole new piece of paper for this because it's going to take me a minute. But if we look at this first step, we'd have this row into that column. Oh yeah, that would overlap, right? And then we could just keep dunking them into the sauces. We have 4 different sauces here, okay? So this one we can do because the number of columns equals the number of rows. These two numbers line up, so we can multiply them together. Pretty neat, okay? Now I'm gonna do this one on another piece of paper just because it's gonna take a little bit of room. Actually, I guess I could just do this. That way I don't have to rewrite it. There we go. The magic of Hollywood right there. So, okay, let's look at this one. So I've got to do exactly what I was just starting on. This one's going to go for a while, right? I'm going to have like 4 different parts. So it's going to keep going. So if I do the 4 and 2 and the 1 and 0, that means I'm going to have 4 times 1 plus 2 times 0. That's going to be my first component. Put that in the, we'll call that the marinara. Okay. And then we'll do the second one. We'll call that one the honey mustard again. Now these are equal. So it's going to be 4 times 2 plus 2 times 2, right? If you think of how they overlap. Now we're going to have to do the same thing, but we've got more dips going on, right? More sauces. We'll call this one the ranch to satisfy Chastity because she said ranch. So 4 times 3 plus 2 times 1, or negative 1. And then lastly, let's do a wild card flavor. Does anybody dip their cheese sticks in anything weird? I mean, I know some people think honey mustard.
Garlic butter sauce.
Okay, that's not weird. That sounds amazing. Okay,
barbecue sauce.
Okay, no, let's go with garlic butter sauce. Very fancy there, in my opinion. By Chastity. Or maybe like a garlic parmesan. Oh yeah, that sounds awesome. 4 by so it's gonna be 4 times 4. Yeah, plus 2 times 6. But yeah, I agree. Garlic butter sounds good. Garlic parmesan. But notice there's no more sauces now. So now we have to switch down to the next row. And look, guys, I'm going to do the same exact thing. I'm going to go into all 4 of those sauces. So it's going to be 1 times 1 plus 3 times 0, right? And then 1 times 2 plus 3 times 2. And 1 times 3 plus 3 times negative 1. And then 1 times 4 plus 3 times 6. Okay? Now I've just got to do the basic math here. So, okay, 4 times 1 is 4. Well, 0 is nice. It makes it go away. So 4. 4 times 2 is 8. Plus 2 times 2 is 4. So that's 12. 4 times 3 is 12. Plus 2 times 1, negative 1 is negative 2. So 12 minus 2, that's 10. 16 plus 12, that's 28. 1 times 1, 3 and 0. Okay, that's just 1. 2, 6, that's 7. Oh, wait, no, that's not right. 2 and 6, that's 8. 3 and negative 3, hey, that's 0. 4 and, is that 18? Yeah, so 22. Yeah, cool. That's it. We're done. Now notice, okay, here is something kind of interesting I didn't mention earlier. Whenever you multiply these together, the order, the outside numbers will be the order of the solution. So this is a 2 by 4 matrix, right? 2 by 4. And it'll come from the outside numbers, okay? Kind of neat. You don't have to know that. That's not a need to know. What you need to know really is that the middle two have, the middle two have to match if we're going to be able to multiply these together, okay? Any questions before? I'm going to give you one just to kind of test to see if you're doing this correctly, okay? You need to try it on your own to see if you've got it. Any questions about this one? Okay. Okay, let me give you a 2 by 2 just to make sure that you've got this going. Actually, maybe I'll change it up a little bit. We'll do yeah, let's do it. Wait, hold on. Yep. Let's say we've got 4, 0, 1, negative 1. Then let's do 2, 3, 5. Let's do another 0. Zeros are nice. -2 and then -4. So try that. Now look, we can multiply these together, right? This is a 2 by 2 and this is a 2 by 3. They match. It's going to cause a 2 by 3. Okay, I want you to try that by yourself. I'll give you a little bit of time to do that. I need some water. Okay, if you're still working on this, keep working. It's not like a race. It's not like if you get done quicker, you get more points. But I'm going to go over it while you're working on it. And now look, so I'm going to think of this row, and I got to dunk it into each one of these columns, right? And they fit, I mean, because this matches. So this winds up being 4 times 2 plus 0 times 0, 4 times 3 plus 0 times -2, and 4 times 5 plus 0 times -4, right? Hold on a second.
I wish it was all this fun.
What'd you say?
I wish all algebra was fun.
Yeah, and if you like just the kind of pattern stuff, this is really very pattern based. And then so we get 1 times 2, and then -1 times 0, and then 1 times 3, and -1 times -2, and then 1 times 5, and -1 times -4, right? Let me know if I get off on, I'm kind of zooming through here, but so if it's wrong, let me know. Something doesn't look right. The first component, I get an 8, then a 12, and a 20, and then a 2, and then it was this 3 plus 2, so 5, and then 5 plus 4, 9. Is that what you guys got? That's right, Chastity.
Yes.
Perfect. Awesome. We're getting it.
Haha.
And you're right. This stuff isn't bad, and it's one of the I mean, not that it's easier per se on the final. We do a breakdown of like what you guys miss, and you know, typically this isn't missed, and I think part of it is because it's the most recent stuff that's covered, and it's not the hardest stuff, you know, we've gone over. Solving zeros and stuff like that was much more difficult algebraically to break down. Okay. I mean, that's it for this section. We'll go over some more stuff. Oh no, you know what? No, because I want to save for the final. This will be it. Okay, yeah, we'll just do 6.3. This will be the only stuff from chapter 6 on the final. So for homework, let's do it starts on page 624, section 6.3. I want you to do 1 through 41. Yeah, 1 through 41, odd. And that'll be the only stuff from chapter 6. That's fine. Okay, I'm not worried about the other stuff. I'll make sure it's not on the final. And that's not a big deal. Okay. Any questions?
You said you'll make sure what's not on the final?
Oh, the stuff from here, hold on. I'm going to switch it to me. Okay. So write this down. Yeah, write it down because I'm going to switch it over. Okay. So this will be the only section that will have content from chapter 6 that's on the final. I've made the final yet, but I can tweak it still. So there was like one other topic from 6.2 I was going to cover. It's gone. Okay. So we'll just cover, it'll just be what's in this homework that you guys are going over. Does that make sense, Chastity? Okay.
Yes.
Okay, good. So get that done. Look back at your test before Wednesday. It will be valuable for you to do that. So that way you can see, just to get a review. The best thing to do is just kind of hash it all back up so you remember it. Because some of the stuff's not that hard. It's just you haven't seen it in a while. Now, I'm going to offer this up as well to you guys. So I have a Tuesday, Thursday, 9:25 college algebra class. So if you want to come in that Thursday, it's the same Zoom meeting. You would click on the same button. So on Thursday at 9:25, if you want to come in it's not going to be additional review. It's just another review. Like that class meets tomorrow. I'm going to go over this same stuff, and then they'll review on Thursday at 9:25. So if you want to come into that class, you're more than welcome to as well. Okay. If you're seeing stuff like after Wednesday, you can come in and ask questions in that class as well, or you can email me. Okay. I'll get back with you. And now if you email me at midnight on Thursday, I might not get back to you until later that Friday morning, but I will get back with you if you email me too.